Welcome to part 5 of my maze game tutorial for Android. Last time we finished the maze generation algorithm, and now it's time to add the player and the exit. So let's start by creating some variables. For the player and exit, it's probably easiest to make them cell objects. Private cell player exit. And we also want new paint objects for the player and exit. Player paint and exit paint. So we can choose different colors for each of them. Now let's initialize the paint objects in our constructor. Player paint equals new paint. Player paint set color dot red, and copy that, paste it for the exit paint, but change the color to blue. Next, I'm going to set the position of the player and exit in the create maze method after the nested for loops. Player equals top left cell, which is cell 0, 0, and the exit equals the bottom right cell, which is cells, number of columns, -1, and number of rows, -1. Now we can display them in the onDraw method. I put them here at the end. Let's start with the player. Canvas, draw rect, which draws a rectangle, and it needs the x and y coordinate of the top left corner and the x and y coordinate of the bottom right corner, and also a paint object. So the x coordinate of the top left is player dot column times cell size. The y coordinate is player dot row times cell size. And for the bottom right corner, player dot call +1 times cell size. And player dot row +1 times cell size. And the player paint. The exit is very similar. Replace player with exit. Let's run this. The player and the exit, not bad. But I don't like that they are partially covering the walls, so I'm going to add a small margin there. Int margin equals, and Let's calculate it based on the cell size. Equals cell size divided by 10. Oh, this should be a float variable. Float. Sorry for that. And now we can add it to the top left corner and subtract it from the bottom right corner. Also for the exit. Much better. Now there's only one thing left, and that is to add movement. For this we have to override the onTouch event method. This one. The onTouch event method is automatically called whenever there is a touch event, and the event parameter holds things like the type of event and its position. So we can check if the event getAction, which is the type of event, equals motion event dot action move, which is when you're dragging your finger across the screen. I want to compare the position of the player to the position of the touch event and move the player accordingly. So first let's get the position of the event. X equals event dot getX, float y equals event dot getY. Now the position of the player, or rather its center, because the player is a rectangle, player center X equals the horizontal margin plus the player's column plus 0.5 for its center times the cell size, and for its y coordinate we need the vertical margin, the row, and that's it. In case you're wondering, this F stands for float. If I don't put it here, it gives me this red line, which indicates an error, because now this 0.5 is handled as a double precision floating point number, but I'm assigning it to a normal floating point number. So you need this F. Now let's calculate the differences between the player's position and the event position, so we can decide in which direction to move. Float difference in x direction equals x minus player center x, and float difference in y direction equals y minus player center y. Since these could be positive or negative, Let's also calculate the absolute values. Float absolute difference in x direction equals math dot abs dx, and the same for the y direction. I only want to move the player if the absolute difference in one direction is greater than the cell size. If abs dx is greater than cell size, or if abs dy is greater than cell size. Next, I want to distinguish which of them is bigger. If absolute dx is greater than absolute dy, we move in x direction. Else, we move in y direction. In each of these cases, there are two possibilities. In the x direction, we could go to the right or to the left. If dx is greater than 0, we move to the right, else we move to the left. When we move in y direction, if dy is greater than 0, we move down, else we move up. Now we have to write a method that moves the player. But first, I'm going to create an enumeration for the directions. Private enum direction up, down, left and right. An enumeration is a data type of self-defined constants. Now to the move player method. Private void move player, and it gets a direction as argument. Direction. Now we have to distinguish the four cases with a switch statement. Switch direction, case up, break, case down, break, case left, break, and case right. When we move up, we decrease the row by 1. Player equals cells player.call player.row minus 1. But we are only allowed to move up when no wall is blocking our way. If player.topWall is false. Now copy that for the other directions. When we move down, we change the row +1 and only if there is no bottom wall. When we move left, we decrease the column by 1 and only if there is no left wall. And finally, when we move right, we increase the column by 1, but only if there is no right wall. To make the change in position visible on the screen, we have to call the onDraw method, but we cannot call it directly. There is another method called invalidate, which calls the onDraw method as soon as possible. Now let's replace these comments with the movePlayer method. MovePlayer right, MovePlayer left, MovePlayer down, and MovePlayer up. This should work, right? Let's see. Nope, no movement. That's because the action move event is part of a bigger gesture, which starts with an action down event. If we don't handle this first action down event, we don't get the following action move events. And how do we handle it? That's easy. We just return true when it occurs. If event getAction equals action down, return true. Even though this would already work, we should also return true after the action move event to signalize that we've handled the event. Now we can click the screen and drag the mouse to move the player. There's just one thing left to do. I want the game to start all over again with a new random maze after the player reached the exit. For this, I'm going to write a new method. Private void check exit. If player equals exit, create maze. And we also have to call it after we moved the player. Works like a charm. This completes the tutorial. I hope you've learned something. Goodbye.